The questions that I want to go through in detail is question 6. In the water wave shown in the diagram, the wavelength is represented by the horizontal distance between the points. Okay, what is it between which one and which one? A lot of y'all gave me L and P, okay, N and Q, M and O, N and P, okay, and things like that. Okay, but the answer to it is actually P and R. Okay, P and R. Why is this so? Okay, so over here, by definition, okay, how do we find the wavelength? Wavelength is between two crests or between two trough. Okay, crest is the highest point, trough is the lowest point. So the wavelength is from here to here or here to here. Right, so wavelength we put it as lambda. Okay, another method of finding wavelength is of course from this point to this point. Unfortunately, okay, L between L and something, okay, over here this point is not labeled, and M and this point is also not labeled. O and another trough, this point is also not labeled. And then why is it P and R? Okay, so over here, okay, there's a very important concept. Okay, wavelength is a length created by one wave. Alright, okay, so wavelength can be found in many places. So take a ruler and measure the wavelength. So from M to this point, okay, it should give you a length. From L to this point, it should give you a length. O, between the two trough, okay, it should give you a length. Okay, so the wavelength over here between the two crests must be equal to the wavelength between the two trough, and this wavelength must also be equal to this wavelength. If you don't believe me, take out your ruler and measure the three wavelengths. Okay, they should have exactly the same length. And then over here, okay, if you take the ruler and you measure the points between P and R, you will get exactly one wavelength. Okay, and the wavelength is equal to the value over here, equals to the value between the two crests and the value, okay, over here. So between P and R, okay, can you see that? See these 2 points? It actually forms, okay, exactly one wave. Okay, this point to this point is exactly form one wavelength. Okay, so over here, okay, you have the wavelength. So please take note. Okay, after measuring the length, you can take this length and you can place it anywhere along the wave. Okay, any 2 points having this length, okay, okay, you can name it as one wavelength. For question 7, what is the unit used to measure frequency? So the unit is actually hertz. Okay, unit is actually hertz. Short form is Hz. Okay, do not give me, okay, F. Okay, F is the symbol for frequency. The unit is actually hertz. Okay, just like length. Okay, for length, people usually use the symbol L to denote length, but then the SI unit for length is actually meters. Okay, so this one is the SI unit, or this one is a symbol. Please get this right. For question 8, write down the relationship between frequency F and the period T. So this is the formula that we have to recall. F is equals to 1 over T. And take note, for period, the symbol is actually a big T. So what is the SI unit for period? It's actually seconds. The symbol is T. Okay, so for frequency, you know, the SI unit is actually hertz. So for question 9, write down the relationship between speed V, frequency F, and wavelength lambda of a wave. So this is the famous equation that you must remember, okay? While you're eating, you must remember this. Sleeping, you also must remember this. Playing, going to toilet, you also must remember this formula. Okay, so V equals to F times lambda, and this is another formula. Okay, so in the wave topic, all you have to do is to remember these two formulas. Okay, now comes a question. A VHF radio station. So you might ask, What's a VHF? This is only a short form for very high frequency radio station. So don't bother about this, okay, if you don't understand. This is a very high frequency radio station broadcast at a frequency of 96 megahertz. Okay, this is mega. Refer to chapter 1. Okay, refer to chapter 1. We have got mega. Okay, we have got giga. Okay, and we also have got this thing called kilo, milli. Okay, for kilo is 10 to the power 3. For giga is 10 to the power 9. Okay, refer to the table in chapter number 1. Mega is actually 10 to the power 6. Okay, so how do we convert? So I will show you how to convert 96 megahertz to 96 hertz. Alright, okay, so continuing the question, the speed of radio waves is 3.0 times 10 to the power 8 meters per second. What is the wavelength of the waves broadcast by the station? Okay, we'll make use of this formula called V equals to F times lambda. So V equals to F lambda. Frequency is given, speed is given. What we have to find is the wavelength. So we'll make wavelength the subject. Wavelength is equals to carrying this frequency over. Wavelength equals to the speed over F. Right? So making lambda the subject, okay, I simply carry the F over. So lambda equals to V over F. Okay, this one please, okay, you must know how to manipulate the formulas. If you don't know how to manipulate, okay, try to use the triangle, but do not depend on the triangle too much. Okay, so V is on top, F and lambda. If you want to find lambda, you cover up lambda is V over F. Okay, so all you have to do is to substitute the values. So what's the speed of the wave? The speed of the wave is 3.0 times 10 to the power 8. So I plug this in. What's the frequency? Frequency is 96 megahertz. So you have to change the mega to 10 to the power 6. So you simply take 96 times 10 to the power 6. Alright, so you have to change 96 megahertz to 96 hertz. And when you divide these two numbers, please remember while you're pressing a calculator, put in the brackets. And you will get this wavelength 3.1 meters. Okay, so the answer is 3.1 meters.